Okay, there you go.
So then what we are going to be doing today is to clone a Git repository and work on it locally. So what we'll do is we are going to bring our work we have done on GitHub yesterday on our local machines. So is font size big enough?
It looks okay to me.
Okay.
Does anyone else have a comment? Well, write in notes and I'll relay if you need.
Okay. So then whatever we did yesterday, so doing commits in our repository, creating new branches, merging branches, we are going to experiment with that on our local machines. So then a small recap from yesterday. So what is our Git repository? So it simply contains all the files and the subdirectories of our project. It has the complete history of our commits. So different snapshots of these files and directories at different times. And it usually contains, well, or not usually, sometimes it contains different branches and tags. And introducing new branches is to, well, have a clearer line of thought. So whenever you're experimenting with something new, you might want to create a branch so that in case you are uncertain, if that's something you wish to have for your repository, you can, well, simply discard it or merge it in the main one if it's a important feature. So what about cloning? So cloning is actually copying the entire repository with its commits and history to our local computer. And it's another way of, well, it's yet another backup for the repository. And then you can, well, work on your local copy of the repository. You can do further tests and run the program if it's a program, or use your favorite editor to inspect different files. And one important thing to remember when it comes to cloning is that if you do commits in your local clone, so the local repository on your machine, these will not appear automatically to the repository where you cloned from. And the other way around, if the repository you cloned from, which is typically called upstream, so if that repository has new commits, then they will not show up automatically on your clone repository on your local machine. You actually have to use additional commands in order to sync your local clone with the repository on GitHub or GitLab, if that is where you have it. So
So
yeah.
it's not a full automatic syncing, but somehow like you tell it when to go. And I guess that will be the push and pull commands we learned.
Exactly.
I think we had heard
and
about.
some of the IDEs can do this automatically, but I think it's important to remember that generally this is not the case. So you will have to do this pushing and pulling, and we'll see how you can do that. So I think maybe we should discuss a little bit what is the difference between forking and cloning, and when do we want to do one or the other?
Yeah. Well, is that a question to me?
If you want, otherwise I will answer.
Yeah. So in my mind, I think forking it's like making your own copy, and cloning, I know the command makes a copy on my computer. So I guess fork is like is everything a fork technically, but when we say fork, we usually mean something on GitHub, like making the own copy of a GitHub repository. And then clone is, well, you can clone your own repository, your own copy of the repository, or you can clone the upstream copy that's not yours. So
Yeah.
yeah.
So I would just add that, so if I only want to, let's say I found a repository on the web, and I want to investigate further, then I may do a fork,
Yeah.
yeah, maybe do some simple commit on GitHub or something. But if it's actually a code that I may wish to run, then I'm going to clone that on my local machine, install that software, run some tests, or run it with some input that I have. So yeah, whenever I actually need to run things on my machine, when I want to do commits which are maybe, I don't know, doesn't necessarily have to
Yeah.
be more advanced, but let's say I just prefer to work on my local machine, then I would go for a
Yeah.
clone instead of just forking it. And it's
Yeah.
not wrong to do both, or it's not wrong to start with one and add the other. So um, that's um, that's perfectly fine.
Yeah. Okay, so cloning
Okay,
gets you the actual files on your computer that you can do stuff with, which
yeah.
I guess is important for anything. So yeah, okay, good.
Okay, so then let's introduce the exercise. And again, I mean, um, we prefer you do this using either VS Code or the command line. Still, I mean, there are things that you can do on GitHub. So if that is the path you want to choose, that's perfectly fine. It will not work for all the steps. Actually, well, not. Well, we'll see with some of the exercises later that some things can be done on GitHub, but now it's mostly cloning a repository which exists on GitHub and bringing it to your computer. So if you have not yet configured Git on the command line, then we suggest you do that. And in this step 1, there is a link to that. And then in the second step, you actually need to decide which is the repository that you wish to clone. And if you were with us yesterday, then you may already have a recipe book, which is a fork of the CR workshop exercises. You may work with the fork that you have. You may also work with the repository under CR workshop exercises. It's really up to you. For the purpose of this exercise, it doesn't matter what you choose. And then we'd like you to create a new branch, this time locally, and make a commit and simply repeat some of the steps that we have done yesterday, but on our local repository. And then step 7 is actually to compare your commits locally with what exists on GitHub, and identify if the syncing has happened or not. So that's about it. Richard, anything else that we should add before going into exercise time?
If you can't do this exercise, do you lose whatever comes later, or is it okay? Like, do future exercises depend on this one?
No, they don't depend. So,
Okay,
and if you
yeah,
cannot, so if you don't want to work, or if you don't want or cannot work locally using either
yeah,
the command line or an editor, then
yeah,
you may just try this again on GitHub. That's
yeah,
perfectly fine. So
yeah. And
so
then
no
they can
need to
come back.
panic.
Okay, yeah. And they
Yeah.
can they come back in 45 minutes and we go to the next one, which they can do. Okay, good to
Yeah,
know.
yeah. And I
Um,
mean, one option is also just to check the solutions that we have introduced. That is also perfectly okay. I think that there is
yeah,
still a lot of learning that can be done by just
yeah,
checking the solution. So
yeah. And then there's a good question on line 105. Step 3, creating branches locally. For this, do we need to be in the same directory of the recipe book? And this goes close to, I think, what might be the biggest problem in the step. So whenever you do the local work, especially from the command line, you have to run things from the command line. Like the command line has to be in the same location where your files are currently stored. And
Yeah,
if you've never examined stuff from the command line, if this is still new to you, don't worry. Like you'll probably pick it up quickly, but it will be hard to learn two things at once. So in that case, don't worry, ask the questions. Um, I did try to cover this in the shell crash course, which I re-recorded for this workshop that you've seen somehow as part of the setup instructions. And
mm-hmm.
if the command line seems too hard, I guess you could take time and watch that again and see what
Yeah.
you can learn there.
So I'll
Um,
just add one thing. So you do need to be in this directory, the recipe book, because well, Git needs to know that the directory you are in is actually a Git repository. Otherwise, it will not understand that. So the short answer is yes.
yeah. Okay. Is that all then? Are we
Yes, that's all. And
ready to
then
go?
what should we say? 20 minutes or 25? 25 minutes, I
It
think
says
we have for
25
this.
minutes.
Yeah.
So
So in case you need
return
to set
at
some things up, you have those extra minutes to do that. So
40. Yeah. Okay. Great. So see you later. Good luck, and definitely write questions in the notes. We're around to help. Okay. Bye.
okay, welcome back, everyone. I hope you had a good try for this exercise. So we have a feedback box in the notes document. If you have missed it, then please check that. But based on the existing feedback, you would like me to demo how to do this via the command line. So this is what I'm going to do in the following. So I have, so the very first thing that one should do, so let's see, go back to the exercise, is to configure Git. I have done that already, so that is fixed. And actually, yes, if in case you do not have done, then I should just show you that you find it under under first episode, getting started and configuring Git command line and editor. So that is what you need to do. And then if that is still unclear, add another plus to that part. And in the second step is to decide which repository to clone. And I am going to use the fork I have done yesterday. And how do I do that? So I need to have a URL for where this remote repository is located, and then copy that. So you may notice there is a green button here close to well, on my GitHub repo page, and I'm going to click on this triangle and copy this link, which is under SSH. So just a short comment on the difference between HTTPS and SSH. If you do not want to push your local changes to this remote repository, which you are cloning, it's okay to use HTTPS. If you do want to push back and you have the rights to do that, then choose SSH. And because this is my own repository, I do have the rights to do that, so I'm going to go for this option. But again, if you are cloning someone else's repository and you are not a member of that project, then choose the other option. So I have copied that, and I'm going to go to my terminal. And the command to clone a repository is git clone. And then I have to specify the path where this, well, the URL where this repository is. And actually, it's not the URL, but it has a certain syntax as I got instructed from GitHub. So I have just pasted that. So this is what I copied from GitHub, and then I enter, and now I have this clone on my repository. So let's see. Okay, sorry, that was very bad. So I have cloned this in my home directory. I'm going to actually move this recipe book recorded into another folder. That was unnecessarily complicated. Oh, okay. That was. Let me just do the clone again. Oh, it's because I already cloned it here. Yes, okay, sorry. So then I have this clone recipe book recorded. So it's a Git repo on my local machine, and I'm going to cd to this directory. And what do I have? So I have all these different files that we have seen yesterday as well. And the next step was to, let's see, is to create a new branch. And how I switch to it. So the command to do that is git switch, and the name of the branch. Let's see. What should I say? Oh, sorry. New branch, and then the branch I want to create it from. I'm going to create it from the main branch. And actually, git switch is not enough because this new branch, or actually maybe it exists. So let's call it modify soup. I also need to add the option create. So what this is going to do is create this modif soup branch from main and then switch to it. It's like a combination of two commands. And to see that I am on the right branch, I'm going to do git status. And you should do git status often so that you actually know what the state of your repository is. But now it just tells me that, okay, I'm on this branch and I have a clean working tree. That means that I have not modified anything. But what I will do is to modify the mushroom recipe. And I opened this file with my preferred editor. You use your preferred editor. And I'm just going to add, for example, this and commit this change. So first I have to instruct Git that I have modified this and I want this modification to be incorporated in the next commit. And I do that with the git add command. So this is like adding the plus button in VS Code, for example. You simply instruct Git that you want to incorporate these changes in the new commit. And then let's show git status again. So this will tell me, okay, you have modified this file, it is staged, and I can now commit it. So I can incorporate this change to the mushroom soup in the new commit. And using the command line, it's git commit -m for the commit message. If it's just one line, so modified, edit, yeah, modified mushroom. And then let's just do git log and see how that looks. So I have a new commit here, modified soup, on the branch modified soup, and then with this commit message. So I could also do git graph, for example, and then I have the whole history of my repository in a graphical representation. And you can actually also see this in VS Code. Okay, and then what was else to do? So I should switch back to the main branch. So git checkout main, or I could do git switch main. So let's do that. So either git checkout main or git switch main. So this is going to get me back to the main branch. So I can check that again with git status. So it tells me that, okay, I'm on the main branch, or I could do this using git branch. This is also going to list the branches I have, the local branches I have, and add this asterisk to the branch I am on. So merge, and then the next thing to do is to add two commits here. So I'll quickly do that. So again, I'll just change some file. What do we have here? Guacamole. So let's do just a quarter of this. And then git add. So again, git add is going to tell Git that I want this change to be incorporated in the next commit. And I should do another commit. So let's do, okay, let's change this file again. And now what I will have eventually is two commits that change the same file. One would think that it would have been better to have one commit instead. That sometimes is the case, but in this case, I've done it this way. So I have smaller changes in several commits. What did I do? Let's sort here. No, let's, so let's say I don't remember actually what I did. So let me open this file again. I had less salt, yes. So I am now committing that the additional change I did to this guacamole, which is not, yeah, less salt. So how does my commit tree look like now? So I had, so now on main, I have these new commits, less onion and less salt. And actually you may see that I have another origin main branch here. So what actually that means is the reference for the remote branch that I have, which is actually behind on my local copy compared to my local main branch. So I can show this in a more concise form using Git graph. So I have these two branches on main, and then these two commits on main, and then this modified soup on this commit on the modified soup branch. Sorry. So let's merge those, and how do I do that? So I use the git merge command. I specify the branch I want to merge. So motif soup and the branch I want to merge into. And if I do not specify this second argument for the branch, then it's going to take the branch I am on when it does the merge. So I click that, and then I'm being prompted with a commit message for the merge. I'm okay with that, so I will just save it. And then these commit messages are going to be opened in the editor that you have set up for Git. So you may have Nano or Emacs or VSCode, and that is okay. So let's quickly do a git graph again. So I see that I have a new commit, which is the merge commit of the main branch and modif soup. So what about the history on the remote repository? So the one that I have cloned from. So let's see, do my changes show up there? And the way I can do that, so I can go to Insights and do, for example, and check the network, or I could just see the history of the commits. Can do that as well. This takes a bit of time. So here, actually, I do not have this new branch, modif soup, that I have on my local machine. So this has not been synced. I can also see just by looking at the code and clicking on the commits. So the most recent commit that I have on this branch is actually from yesterday. So the local changes I have done are not yet incorporated on the remote repository. Final question number 8, where are the remote branches? So how can I see all the branches? So if I just type the git branch command, this is only going to list the local branches. So local branches that I have defined on my local repository. In order to see the remote branches as well, I have to add the option --all. So these are not only going to show the local ones, but also in red the branches which are defined on the remote repository. Okay.
So there's getting to be questions to note some people have lost track of what we're doing. So I think the most important thing here is that this is a demo for the recording mainly. So we showed one of the paths, but it's not needed for what comes next. So don't worry too much. So don't let this stop you from things. You've sort of seen this command line method, and we will get more used to it later if it's the path you want to take. But you definitely can do your work with vscode or something like that that shows other stuff.
Actually, there
Should we
is
go
one thing.
to
Yeah,
yeah?
one thing. So I did fail to show how you can actually track a remote branch. And so the command to do that. So let's say that, for example, I want to track the branch Alex fruit salad. So then I can do git switch followed by, git switch followed by the option --create, the name of the local branch, and then the name of the remote branch. So in this case, origin/Alex fruit salad. And then I type that, I type enter. Alternatively, instead of using git switch create, one can just do, I'll show you that. So git switch followed by the option track, and then just the name of the remote branch, and then it's going to take the same name for the local one. So that's equivalent. Okay then, but we
Yeah.
definitely need a break now, right?
Yeah, so a lot of what Dana showed was sort of more advanced stuff that's not in the lesson. So don't worry, it's not needed for the first day-to-day work and is stuff that you can pick up later over time. There is one question about what head means. It's something that we've been seeing lately. So the name head comes from like the recording head of a magnetic tape or something like that. And basically, it's where the changes are being made. So whatever your head branch is, that is where new commits would go and what will be modified when you run the git commit or git merge command. But yeah, let's go to a break. We can add more into the notes there. So with a 10-minute break, we're back at 9 minutes past the hour. So take your break, keep the questions coming in, and let's we'll talk then. Okay.
Okay, see
Bye.
you after the break.
Hello, we are back. There we're going to go on now to the next phase of the lesson. But yeah, that was quite a challenge what we just did there, seeing everything from the command line. So if you are sort of familiar with the command line, then maybe you saw the general idea of what's there, but still, even if I see someone typing a bunch of stuff on the command line, unless I already know what's going on, there's not much chance of following it. It's always like, okay, here's a general idea, and then I need to go find the written material and understand it later. So that's basically what you can, or how you should interpret the previous demonstration of the exercise. So it's what you can, like, it's how we would be doing it, knowing things, and now it'll be recorded for the video so you can review later. But it's not something like, if you didn't follow everything there, don't worry. I mean, that's normal. It's yeah, it will
Yeah,
take time. That's why we have the different tracks for VS Code, RStudio, and whatever. So over time, slowly as you do things, follow up and um, learn more over time. And with that, we're going to go on to inspecting history, where I
yes,
believe so it doesn't depend on anything we did now. And you start by cloning a new repository. So no matter how weird things have gotten now, it's okay. It doesn't affect things later. And in fact, over the next few days of the workshop, we do similar things to today, again, from different angles, and you will have more time to see it over and over again, and we'll slowly pick things up. So that's just another reason not to worry. So
yeah,
with that, I'm going to swap to Diana's screen. There we
yeah.
go.
And I will just add
And
that if you are interested in the command line, you can go back to the lesson yesterday and inspect the tabs under the command line, then and get more insights into
yeah,
these commands. But it's okay to do things in VS Code or on GitHub. But yeah, inspecting history. So what do we actually want to do when when do we want to inspect the history of a repository?
sorry, I was answering
So
Note's
Richard,
question.
when
What was the
yeah,
question?
sorry. So when do we actually
Yeah,
want to inspect the history of a repository?
yeah.
So
So
maybe I'll start.
yeah,
So for example, if I discover a new repository, then the first thing I'll do is to check, okay, what's the current state of the repository, and then look at the history of those commits. And we've seen some of that yesterday by, well, clicking on the clock on the GitHub repo. So that is helpful to get on some insight on what has been done for that repository. Yeah,
yeah.
what else?
So for me, I guess there's two levels. One is quickly seeing what I've done lately in order to know where I am, what I need to do next, and so on, or to see what I might have just messed up. Um, for deeper history inspection, at the end of this lesson, I don't know if we'll actually do it as a demo. You can try it as an exercise if you want, but there's a way to search all of history to figure out where a certain bug was introduced. So if you find something that's broken and you don't know where it's broken or how to possibly fix it, using these kind of things can point you exactly, okay, this is where the problem started, and then you can more easily solve it.
Yes, bug hunting, that's a
Yeah,
really good case for actually
yeah,
inspecting the history. And this is what one of the exercises that we'll show today. So as usual, I mean, you can choose different paths, and some things can be done on GitHub, some can be done on VS Code. By far, the command line is the most powerful way to do that. It's also the hardest one to understand and get used to. So I think it's not wrong to actually combine different paths for inspecting the history and yeah, choose the one which is most suitable for what you are trying to achieve. But we'll introduce in the following some tools that you might find useful. And again, I mean, this depends on what you actually want to find out about a certain project. So let's start by looking at this repository. So a remote repository on GitHub, and so I just quickly open it here. So this is a very large repository. It has like, oh, I don't know, I think it has 7,943 commits. So that's really a very big one. So it can be actually quite overwhelming to look through this whole repository, and you might, well, you might not even want to do that. But I'm going to, let me open this particular link here, which is going to show a quite nice graphical way of seeing the repository. So what it does, it's actually looking at one particular file, the README RST file, and show the history of this file over time. And this is maybe not so easy to see on this black background, but it starts from the latest change to this file done by a certain user. And if I can use, for example, the left and right arrows to go back in time and see snapshots of this file or changes in these files introduced by different developers. And this tool actually works not only with this repository, it can it works with any repository. So you would just need to change the repository name with yours. So where the so change let me show here instead. So change the location of the repository and the particular file that you are interested to look in. So it's one visual way to show a repository. It's well, not necessarily very useful when you actually try to find a bug, but if you want to present a project to a person, that may be useful. But what other tools are there to actually help us find bugs or new features, new functions that have been introduced in a code? So one of them is actually git grep, which is similar to the grep command that maybe some of you are familiar with, and it's typically used with some argument. It can be plain text, or it can be some expression. So this is useful, for example, let's say you know that there is a function somewhere in the code, but you don't know where. You want to find it. And then you can do some git grep and the name of that function. It can be used with some longer text that's possible as well. It can also be used with different well, arguments for this command, this simply means that ignore the caps for the string that I'm trying to find. So again, I mean, if you know that there are a bunch of lines, fix me in the code where you or someone else has introduced the code in order to help you remember that there are some things you need to improve, maybe some code documentation that in code documentation that you should add, then you can use this command to find that. So git grep, what it will do is going to search for the current state of the repository, right? So how it will check the content of the files in their present state, which sometimes is not what you want. You want to go back in time and see, for example, you knew there was a function or a piece of text that has simply disappeared from the code, and you want to know who has when that has gotten removed. Maybe the person that has removed that. So the way you can do that is with the git log command, but by using this option -S, which is this so-called pickaxe option, and followed by the text that you try to find. And this is advanced. It's useful if you know what you are looking for in the code. But yeah, it's not maybe not so easy to remember. So you can let's say you did find a bug in some version of the code. You can, or you just want to inspect a certain commit that your collaborator has done. You want to see what are the changes introduced with that commit. In the command line, you can use the git show command followed by the hash of that commit. You can also do this, for example, on GitHub by having the link of the repository, the URL of the repository, and then followed by this text commit, and then the hash of that particular commit. So that is going to give you some information on what has been committed. So I'm actually going to just open this link. So again, this shows all the changes introduced in this commit with this hash. And one thing which is quite interesting is that I can click on this icon, browse files, and then I can see the state. I can see all the files in this repository at that point in time. So for as they look like for the commit 75 and so on. So how they looked actually 5 years ago. So that's quite a nice feature of GitHub. And then, sure, I can do this on the command line, but if I don't like to work on the command line, then I can view that on GitHub. So we talked a little bit about Git blame and Git annotate yesterday, and this is very nice to see. So this is very nice to use if you want to track all the changes that have happened to a certain file. So let's assume that I want to look at this convert matrix Python script from this networkx repository. So let's just open this on GitHub. So I want to see how has this file changed over time. So then line by line, I'm going to see the person that has last modified a certain line. And yeah, I mean, there are really lots of changes to this particular file. Some some older, some newer. One really nice feature of GitHub that does not have a counterpart in either VS Code or the command line is this icon here. So this is called blame prior to change. It's actually very hard to understand what it is just from this name. But what it really means is give me the commit that that is prior to the one that modified this line. So we can see from here that this particular line has been modified in the commit. Where is the hash? I don't see the hash, but it has been modified February 22nd. But maybe I find out some way that this commit actually introduced a bug, and this bug is in this particular line. I am not interested in this commit. I'm interested in the commit which was before this one, because then I know that, okay, that version may actually work. So I want to start from there. And the one way I can find that information on GitHub is with this. So if I click on this, I get to the commit prior to this one. This is rendered very funnily.
Yeah.
Sorry for that. So then, yeah.
Weird.
It's very weird.
Business.
So I think it's because the window is so narrow. So this is the hash of that commit, the prior commit that introduced that change. And then again, I can investigate the files in this commit. In this case, well, it shows the pi metrics, but I can also browse the files if I go to I could browse all the files if I go to the main one. So am I going too slow?
Yeah, should we get to the exercise soon? And then we'll have some time before lunch to go over it.
So what would we want you to do in the exercise? So we want you to explore some of these so-called archaeology commands on this network X repository, and this is where you find it. And let's see. And then what we would like you to try is to find a certain line in the source code that contains this text. Find out where this line was last modified and inspect that commit and try to create a branch which points to that commit and see how you can bring the code right before that commit. And this may not be possible to do depending on the path that you are choosing, but it's okay to skip. So give it a try using your preferred path, and then let's see, should we do this for 20 minutes?
Yes, that's what it says. So we'll return at 48 past the hour. Okay.
Okay, then.
Good.
I'll see you
So
then.
yeah, do what you can, and and whatever we do after lunch doesn't depend on this. So if you can't do everything, that's okay. This is more of experimentation. So experiment with whatever is interesting to you. Okay. Bye.
Okay, welcome back, everyone.
Hello. Yes. So now if we look at the notes, there weren't too many questions relative to before. So that's hopefully a good sign. Hopefully a sign of things were going well instead of there being many problems. If you would like us to do something, you can write here which of the steps you would like to see demos of. But there's not a clear question which one we should try to follow. Jenna did relatively good demos before anyway, and I don't know if we can do better than that now. One option is to do the advanced Git bisect exercise to show. Do you think we have time to do that?
So I think, yeah, we can definitely introduce it, and yeah, sorry, I was just writing here. Yeah, we can definitely introduce it.
Yeah.
So
Or is there any
scroll.
general discussion we should do?
So no, not before lunch. I think, yeah, let's
Okay,
let's
yeah,
show Git bisect, and then if by the end of this people
yeah,
well, if we still have time and people want us to
yeah.
demo something, then we can do that.
Hmm.
I think
Yeah, okay,
it's, yeah, just some words on Git bisect. So when is
yeah,
this actually useful?
yeah.
So
What's the point?
it's useful if you have a code that you can actually test and decide whether it's good or bad. So you have some tests that you are running, and then it tells you that no, there is a bug in this code. You need to revise it, or the test passed, and then you can deem that code as a working code. So this is of course not, well, always possible if you have a repository that may just be a collection of files. So it depends. I don't know.
Hmm.
So the way to use this command, git bisect, is, okay, you go to the GitHub repository, which is, well, the local copy of your GitHub repository, so your local repo, and you do git bisect start. So that this triggers a certain algorithm with Git. So in the following, what you need to do is to find a good and a bad commit. So you specify git bisect good, followed by the hash of this good commit. And you also need to specify a bad commit, so a commit that has some error or anything. So git bisect bad, followed by that hash, or it can be the name of the branch if it's the latest commit on that branch. Once you have specified a good and a bad commit, the order doesn't matter. So you need a good and a bad commit. Then you, well, automatically Git is going to run this bisect algorithm and take you to a commit which is between this good and bad commit. And then what you need to do is deem that, okay, this commit that I am on, so you can check that with Git status, for example, which commit you are on, is that a good or a bad commit? And you usually do that by running some tests. And then you either say, again, git bisect good or bad. And then once you do that, the bisect algorithm is going to run again automatically, and then you are going to a new commit. And this cycle continues until you find the commit that broke your code. So there is an optional exercise that we are not actually going to do, but you may try to, if you are interested in Git bisect, then you may try to do this on your own. So this is simply a Python script that calculates pi. And at some point there is an error which has been introduced, and your task is to use this command to find where this has been when this code has been broken. And there are some hints on how you can achieve this. So again, this is useful with repositories used for code development. And when you have a clear way of identifying whether your commit is a working one or not. Richard, anything else that we should say about bisect?
Not really. How many times have you used bisect before?
Oh,
I think I might have used it
I
once, but I don't
yeah
remember what it was for. So
yeah. So I
for me,
think
it's been a very rare thing.
it is actually better to have tests along with your code, and we'll discuss testing during next week, so that you don't even get to push your code before you make sure that it is working as expected. But yeah, no, I do use it every once in a while, but it's not very often.
Yeah. Okay, so what can we expect after lunch? I believe that is the
Yeah,
preparing your own
so after
project.
lunch we are going to do the reverse of what we've been doing in the morning. So instead of cloning our repository from GitHub to our local machine, we'll take what we have on our local machine and put it on GitHub. So that's what's waiting for us after lunch.
Yeah.
And
Yeah.
then we are also going to discuss some best practices or guidelines on how to use Git. So we'll have a discussion around that.
Yeah. Okay, great. So let's go. See you after lunch in about an hour. Bye.
See you. Hello, welcome back everyone. I hope you had a good break. So now,
Yeah,
Richard,
I had a good lunch.
that's
So
good.
what's
Yeah,
next?
me too. So so in the following hour, what we are going to do is to take a local directory we have on our computer, transform it into a GitHub repository, a Git repository, sorry, and then we are going to share it online on GitHub in this case. So we are kind of doing the reverse of what we did in the morning when we clone something existing on the cloud and bringing it to our local computer. So we do it backwards.
So this is basically the starting point where if someone's already doing something, they use the instructions of this lesson to make it Git and to make it where other people can see it.
Yeah, exactly. So let's imagine you've been working on your project for a while, and at some point in time, you realize, oh, I should actually version control this, and I should share it with my colleagues so that they can test it, run it, provide feedback, see how we get this forward. So that's a good reason to version control it and share it with other people. And then actually sharing it does not necessarily mean with others. It's just having like an additional copy of your repository on a cloud platform. So if something happens to your computer, you have a backup for you. And once you are ready to share it with others as well, then you can add members to your GitHub project and evolve it from there. So, but yeah, sharing it with your future self.
So you can put it on GitHub, but it's a private repository. So it's only serving as a backup and you're not sharing it. Okay.
Exactly. So you can choose, do I want this repository to be private? Do I want it public? So yeah, there are some restrictions how many private repositories you can have and how big they can be, but for small ones it's really no problem. You can have it private, and maybe it feels safer to start that way. And once you're comfortable, then you can open it up to the public.
Yeah.
Okay, but
good.
So how do we actually do this? So
I guess the starting point is you have some files in a directory, and you know where the directory is.
Exactly. So that's important. So you have a collection of files under one directory. You may also have subdirectories in that directory, but this top directory you want to that contains all the needed files, you initialize that basically as a Git repository. And then you may start tracking different versions of your files. You have different commits, and at some point, well, you push this to GitHub or GitLab or some other cloud platform that has version control. So the point of the exercise for this hour is to select a directory that you have or create a new directory. You can call it my project or call it something else. Create some new files in it or copy some files that are not so sensitive that you feel comfortable later on to putting on GitHub. And that is going to be your GitHub project, right? And so that is the project that you are going to transform into a GitHub project. So in order to transform it actually into a Git repository, you have several paths to do that. You can either use the command line if you're comfortable with that, or you can use vscode or GitHub. It's really up to you. But what we want you to do is to transform it into a Git repository, and then move this into GitHub or GitLab if you actually prefer to do that, although we are not showing that in the solutions. So anything else that we should hint when it comes to this?
Yeah, so we want to give a lot of time for this because it will be a while. Is there anything we should demonstrate before?
Yeah, should I demonstrate maybe how to actually do this on maybe, I don't know, VS Code?
Maybe you could do the starts of it and then we give some time and then you finish the rest.
Okay, then I will start
good.
and you should stop me when you think I've gone.
Okay.
Yeah. I've shown enough to get people started. So I have VS Code open here. And what I need to figure out now is where is the directory that I want to turn into a GitHub, in a Git repository, sorry. So first I need to make it a Git repository on my local machine. So I'm going to go to this Explorer bar and then open file. Actually, I will do instead from the top menu, which you don't see. So I'm going to click on file, open folder, and I'm going to go to CRD2. And I have one directory there, which is called my project. And it's not a Git repository, so it only contains some files. So I will select that as
okay. So you made
a
this
directory
in advance
to open.
To get ready.
So yeah, sorry, say again.
You made this in advance to get ready.
Yeah, I made that in advance. But so what it is one directory which I have on my local machine, which contains two files. And those files that it contains are called myscript.py, so it's some Python script. And there is a file which is called license. And VS Code is, whenever you have a certain file name or extension, it's going to show this nice icon so that you know what programming language it's in. But in all honesty, these files are empty, so don't think anything fancy. It's just a demo. Yeah. But now, so I have these two files under the directory called my project. And and this is not a repository yet. I have not version controlled these files, but I plan to do that in the following. So then I want to transform this into a Git repository. And the way I do that is I go to source control. So these like commit lines of commits which merge or diverge. And then I have the option to initialize this repository. So initialize repository means transform the existing directory into a Git repository.
Okay, so from the command line, that's the equivalent of Git init.
Git init, yes. Okay. So then what I have, I'm going to close this, it's distracting. So then I have this window here, which shows me that I have two files licensed, my script.py, which are untracked. That means that, okay, I initialized as a Git repository, but I am yet to do the very first commit. So these files are yet untracked. And then what I should do is I should tell Git that, okay, start keeping track of these files. So it's similar in the command line with git add and the file name. And then I click on these pluses, which means that it's going to stage these changes. So then these are staged, which shows as A, like added to the index, in other words, but just think of it as staged and ready to be included in the next commit. And then I can now commit this modification, so the inclusion of these two files in whatever I am tracking with Git into my very first commit. So I'm going to give it a commit message here, start tracking my project. And this is the equivalent of git commit -m start tracking my project. So instead of typing the commands, I click. Yeah. So and I go to the stage where I transform my local directory into a repository tracked with Git locally. So I can see, let me show one thing. So there is actually a graph here, which is similar to Git graph, but I only have one initial commit yet. So I am on the main branch, which is shown highlighted in blue. It shows the committer and the time of the commit and the commit message and which files have been changed. And also at the bottom, actually the hash, the shortened hash of this commit. Yeah. So the next thing would be now to move this onto GitHub.
Yeah, and how do we do that?
Yeah, so should I do that as well? So if I were to do it in VS Code, actually VS Code can do this for me by clicking here, publish branch main. And then what I need to do is to tell VS Code, oh, but where on GitHub do you want your project to be? And it even gives me the option to publish it to either a private or a public repository, by default with the same name as the directory name, but that can be changed. So the local directory name does not have to be the same as the GitHub repository name, although it's easier to keep track of them if they have the same name. But so I'm going to make this a public repository. So then I click this, publish to GitHub public repository. And the first time one does this, one actually has to authorize VS Code to publish on GitHub. So it's going to, you will be asked to authenticate to GitHub, and yeah, so that is a necessary step for the very first time you use VS Code together with GitHub. And then actually I want to show you those messages, but
is there a window open up that's asking about the authentication?
yes, so there will be a window opening up, and actually,
Yeah.
well, there will be a browser window
Mhm.
on GitHub that will
It's
ask you
not
to
there.
authenticate. And if
Okay, yeah.
you, so just follow the steps. Well, read
Mhm.
what is being prompted, and yes, you're going to have to agree that to allow VS Code to make changes on GitHub. And if you're happy with that, then yes, you should authorize that. So one thing I wanted to say, so when I created this repository on GitHub via VS Code, then actually it asked me if I automatically wanted to fetch things from GitHub. And what does that mean, Richard?
Can you ask it again? I was looking at a question here.
VS Code asked me if it should automatically fetch commits from the GitHub repo.
So I guess that means it will automatically do a pull whenever you do things. I guess that could be
On
useful.
the remote repository. Yeah. So that's really, well, it's for you to decide what's best for your project, if you should do these automatic pulls or not. So that's in general, it is a very good idea to keep track of the changes on the remote repository on GitHub or GitLab with the ones on your local machine. So that's generally good. And actually, whenever you start working on your local version, it's good to do a pull or a fetch. So they are almost the same, not really. Okay, but now I think it's good if everyone gets to try this, and you can choose to do it in VS Code, or you you can choose your preferred project. You can either do it in the command line, so it's really up to you. And
There
then
is one question about saying GitHub has removed password authentication. So in order to do this from the command line, you need to use the SSH key method and not the HTTPS method. HTTPS can work with an authentication helper or something extra, but that was sort of an extra thing in the install instructions, and I'd recommend, unless you want to go dig into things, use SSH for command line. Otherwise, stuff can happen. And if you use VS Code, it handles it via the HTTPS and web browser all automatically, so you don't have to think about it.
So that is simpler in a sense.
Yeah. Okay, so we do exercise until it says 25 minutes, so 16, that's 40 minutes past hour.
Yeah.
Okay.
Okay then.
Great. Or I guess
and I'll see you in
43
25
past
minutes.
hour. Yes, see you in 25 minutes. And keep asking questions and notes, and we keep helping. And yeah, bye.
Okay, welcome back, everyone. From the questions and answers, it seems you did have a try at the exercises, and most of you have been successful. I think that it may be worth actually to show question 47. As some of you have proved me wrong, that you can do some automatic pushes to GitHub if you install CLI, for example. So yeah, default it's not possible by design, I'd say, so that it's kind of safer, and it has an increased threshold to be able to create these remote repositories automatically, but there are ways to do that, either on GitHub or on other platforms.
Yeah. Yeah, that was also a new one to me. Question number 48 here. So there's lots of things that can go wrong if you don't do all the commands in the right order. And that's sort of unfortunate. It would be better if it was more obvious and less ways things could go wrong. But yeah, like I'd say when you get these kinds of problems, try asking someone and see what you can do. And
Yeah, and sometimes, actually searching for the error on Google or your favorite chatbot can give you some insights on how to fix this.
yeah. For deleting repositories locally, I guess that's something we haven't said yet, I think. So the Git repository, it's nothing magic. It's basically a bunch of files. There's the files you see that are the code files you're editing and using, but there's also a hidden directory called .git inside of it. And that's where all the repository information is stored. So if you delete a folder, then you've completely reset it. You've deleted the history and you've deleted the files there. And you can clone it again and restart and try it a different way. And that's okay. Even like all of us, whenever a project gets really weird, we're just like, okay, so let's either move this out of the way or delete it and clone it again and get back to the original state.
Yeah, and actually the
And
suggestion of, so if you have not actually changed anything in this remote repository, just redefining the origin, the so-called origin. So the URL for the remote is better. So we did get a suggestion. Actually, we got the command here how to do that. It's git remote set URL. The name of the remote, which is by default origin, but it can be called something else, and then the git at, and so on, the GitHub location of this repository. So yeah, that's definitely better if there are no changes to this remote.
Yeah. So let's see. I will switch to my screen here. I hope.
Yeah, and while you do that, so I'll just comment on question 50, or the note in 50. It's like trying VS Code makes you actually drop the command line, and I think it's it's true. It does make life easier sometimes. I also think that it's the features that VS Code is introducing are expanding when it comes to using it with GitHub. So for some things, I think complicated commands, it's maybe easier to use the command line, but if you use it in a basic to intermediate way, VS Code is already powerful enough. So there is no need to learn these commands. So yeah. Yeah, it definitely has the most of the stuff you need to do with GitHub and Git.
Yeah, I also think it's a good balance. So use your editor for what makes easy, but you can always drop to the command line for extra stuff. It's not two different Git systems, but one with two different interfaces.
Yeah, and I think one nice thing is that you also get to have a nice editor together with your code. So that's one thing I like about VS Code as well.
Yeah.
Okay.
So here we have some, yes, here we go, remote repositories. So we're doing this with GitHub as the example. A very similar thing works for GitLab. So for example, your university may have its own GitLab, and things will be slightly different. The website will look slightly different, and the paths will be slightly different, but overall, the same kind of idea. And there's other smaller ones you can use. For example, Bitbucket is one I've seen some people use. You can also store Git remotes on any server that you can SSH to. So for example, when I was doing my thesis, I didn't want to send it to any other place, and not that they existed at the time really, but I could store my work on my work computer, for example. Okay, and this last bit here, so by putting it on GitHub, you make it available for other people to see it, but these aren't permanent things. So GitHub exists as long as your account is active, but it can disappear at any time. And when you really want to make code available for long-term things, like as part of a permanent paper, you want to archive the code somewhere else. And that's something we'll talk about next week with stuff like reproducible research. But now I'd propose, if there's not much else, we head to a break and see what comes next. Are there any? There's a few more good questions here, but I think they're answerable right here. So let's let the questions keep coming in. So after the break, we talk about practical things. So what do we actually do? Do each of us actually use what we teach? We can talk among ourselves and any other instructors that happen to be around, and you can hear the inside story. So do prepare your questions, go ahead and start asking them, and maybe you can see there's a tail on my desk, so hopefully you get some entertainment from cats when you get back. Okay, great.
Okay. See you after the break.
See you after the break. Bye. Welcome back. There were a lot of good questions in the notes here. But I propose that we first go through the practical advice parts, and then okay, you can see Cats is roaming around here looking for trouble. I hope I don't have to go get up and solve problems. Okay, yeah. So we do the practical advice, and then we take the rest of the time doing Q&A, which can also be practical advice questions, but we'll go over a lot of these questions here. So for practical advice, are there any other instructors in the studio who would like to join us? So we're going here to this. Hello, Michele.
Hello.
So Michele will be instructing next week with us, I believe. Okay, I'm losing. My mouse cursor isn't working properly. This is not good. Let me fix something. Okay, yeah, so practically speaking, what should we and should we not do? It's this part right here. So, yeah, the main question is, of all the things we've talked about so far today, what do you actually use and not use? So should I go first since I asked the question?
You go first.
Yeah, so if you ask me, so definitely I use Git for almost every project I do. If I'm making code editing files, I may as well have a record of what the previous state was. And if I don't, say more than half the time, I'm going to end up regretting it someday. And it's really easy to make a Git repository, either from the command line or editor. And when a project is new, I basically commit everything. Like if by 2 days from now, all the code would change anyway, all that really matters is I have something. I don't care about every commit being perfectly atomic with a great message and so on. But as projects get older and it becomes more mature and like other people might be using it, then I make sure that every commit has a good message because other people might pull and see what the new stuff is. I make sure that each commit does only one thing. So if I break something, I can undo just that part and so on. And it sort of usually comes naturally. Most of my stuff somehow goes on to GitHub, but not everything. Private stuff I don't, not even in public repositories. What about you all? Michele, you're next in the list.
Yeah, I might say, yeah, I tend to use Git a lot, even just for sharing data. So it's possibly an improper use of Git, but just to share data between different hosts. Yeah, I mean,
Yeah.
and yeah, but yeah, maybe there are some things we saw today that I don't use a lot. Like for example, Git bisect. I mentioned I used it, but a few times in my life. It was actually possibly
Yeah.
a bit of a lifesaver. But yeah, yeah, and I think a lot of we discussed a lot of things that I use rarely. Because I
Yeah.
try to make my I try to make sure that the last commit I make, like the current state of the repository, is the most important one by using testing, for example, automated testing. But yeah, but when this when I made a mistake, then it's really nice to have a look at all the Git
Yeah.
annotate, Git blame, or all the logs, or what the log can give you. I think that
Yeah.
I learn every now and then something new that I think, oh, that's actually interesting. So I think it's a long
Yeah.
journey to actually be able to use
Yeah.
Git efficiently and in a way that actually suits you.
Yeah. Deanna, what do you
Yeah.
usually do?
So I use Git for some very few private projects, but usually in collaboration with others. And I prefer to use the command line, but for some of the projects, I just find it easier to work on the web. So if I know that it's going to be one commit, one file, then I just add it on the fly on GitHub and not bother about cloning it on my local machine. So it's convenient sometimes. And then when I do work on the command line, then it's git status all the time. It's my most favorite command, my most used command. And yeah, I find, I mean, the command line has increased flexibility in what you are actually trying to do. It's also faster for me sometimes than just clicking. Sometimes I get lost in all this clicking, but it's really just a matter of preference. And I do use GitHub as well a lot. So, and sometimes GitLab. It really depends on the collaborators. If well, we have some more sensitive projects for which we want GitLab. So
Yeah.
so that's great as well. Yeah.
Yeah. If we look at this page here, let's see what it recommends. So if you're working on the command line, use the git status command all the time. So not using git status is like going for a long walk and not using your eyes to see where you are. So eventually you might make a wrong turn, and if you aren't aware that something is like you've turned off the wrong way, it can go really bad before you correct yourself. But if you do see that something doesn't quite look right, it's usually pretty easy to take a step back and say, okay, yeah, here's the command I missed, this or that, whatever. But
Yeah.
even from VS Code or other editors, it's good to know what current branch you have out and what's modified and not, and so on. So use the different status information it has. For commit messages, yeah, so my best, oh yeah, go ahead.
Sorry, I wanted to say one thing about using Git status. So if you're using an editor like VS Code, they can have their own status. So it's better actually to compare the things you see in your editor with if you plan to use it both at the same time from the command line and the editor.
Yeah.
Sometimes there are some weird things happening because the status is not the same in the command line and in the editor. So yeah.
Okay.
Be aware
Good
of that.
to know.
Mm-hmm.
Yeah. Here you see some advice for commit messages. So the convention is that there's one really short line first, like less than around 80 characters, a terminal width, that is used for summaries, and then any longer details here. So it's, well, as I think we've said before, my philosophy is don't let perfection get in the way of getting stuff done. There have been times that I haven't committed stuff because I haven't wanted to make a good commit message, and it just keeps piling up more and more, and it never gets done. So there's times when I'll come back to a project I haven't worked on in a while, and I see there's stuff in there that's not committed. Instead of saying, let's see what happens, I just make a new commit immediately that says uncommitted changes that I found around. And well, then not perfect, but at least whatever I start to do in the future, it can keep it organized. But the more stuff that's going on, the bigger the project and the more people that might be reading it, including yourself in the future, you can get more and more advanced here. Like you can cross-reference relevant issues, you can explain what went wrong.
And also practice makes perfect. So just
Yeah.
start small and then you'll get better at writing commit messages. So
yeah.
And if you don't, then that's also okay.
Yeah.
And I also would add, there are also ways to amend your commit messages if you make mistakes, or to you can do some weird, obscure stuff with your commits if you really need to. So one thing I wanted to add is that about the content of the commit message. For me, it's really important to mention the context where I've done something. For example, if I'm fixing a function, I wouldn't just write the function that I fixed, but also, for example, if it's a testing function, or if it's not, so to make sure that when I look at the commit log, I'm able to figure out if a commit is relevant for what I'm doing or not. So.
Yeah. I guess one way to look at it is pretend you're telling someone to do the commit you just did. So it'd be like fix bug of displaying the output, or add feature of such and such. And then, yeah, this imperative case. Let's see what comes next. What level of branching complexity is necessary? So branches is something we've gone over a little bit here, but not in great depth yet. But simple projects might have only a main branch, and you put everything there. If you mess something up, well, it's only you, and you can go back and fix it, and that's like, it's less work to fix stuff if it goes wrong than to keep stuff from going wrong in the first place. If there's ideas that you think won't be finished, or you need to be kept separate because it might break things before you can fix it, you can start using branches there. Or things where you want to make lots of small commits while you're developing, but in the end you might just say, no, I don't want this. And then you go back to main and ignore everything you branched. Tags are good for important milestones. I think there was a notes question earlier about when to use tags, and that's something like what's it called? Like, okay, this is the version I submitted, or this is the version
Yeah,
which
releasing a
is
version.
for the paper,
Mm.
that kind of stuff. Yeah. And the more people that get added, the more that you would use branches and things like that. So tomorrow we see the highest level where you use branches for everything, and then there's always someone, or there's a chance for someone else to look and see a change before you start, before it gets accepted. Have we talked about staging much yet? I don't
Very
think we.
briefly. I just mentioned it very briefly when I
Yeah,
worked on the
yeah,
command line. But yeah, tell us some more.
yeah. So staging is a way. So I guess maybe you remember the git add command where we say git add and it prepares something to commit. And when we type git commit, it commits everything that was added. So this is good when you make multiple changes at once. You can decide what you need, or you can, yeah, or you just want to verify things or have a small checkpoint before the commit.
Yeah, and I
To
would
be
just add
honest,
it's like, oh sorry, it's the same as adding the clicking on the plus button next to a file in VS Code. So that is staging as well.
yeah, and it's useful. I often add things first and look at it and then commit it, but also there's plenty of times I just commit everything or use the git commit command in a mode that adds it and commits it at the same time, because stuff's so small and there's not really any doubt in my mind what's going wrong on. And if I do make a mistake, well, I don't really care because no one cares about the project that much. How large should commits be? Or is anything else about staging y'all have?
No, I think it's good.
So how large should commits be? Does anyone
I think
have
in the beginning it's better to commit more often. And then as you get more used to Git and more confident about how much to introduce in one commit, then they can be larger. But anyway, it's good to have no more than one feature or important modification per commit. So then, as Richard said, if something went wrong in that commit, you have the possibility to revert those changes.
In other words, one could say you should have only one thing that can fail in a commit, let's say, so that you can tell which thing was.
Yeah. But without a doubt, there's times when, or what if I'd say for me, as small as possible, but sometimes it's not possible just because I don't have time or energy, and then I do a lot and hope it's okay. So yeah. And it depends on who's going to be looking at stuff. If it's just for you, then you probably won't care. If I'm contributing to a project like NumPy, they probably do care and need it to look exactly correct. Is that all? Yeah. So the next lesson, next part, if we go to it, is related. I'll click back and it is what to avoid. So let's see what's here. So this says commit message that explain what's been changed but not why it's changed. So if it's not obvious, like the code will show what has changed. Perhaps it's more important to explain why something has changed. Again, it matters more when projects gets larger. I think that being too pedantic just makes people not record everything or
Yeah,
anything.
and also what is obvious to you may not be obvious to others. So I think it is good to make an effort of explaining why you introduce that.
Yeah.
And maybe it's obvious to you now. Well, maybe 3 years from now, it's not gonna be that obvious. why
Yeah.
that change got implemented. So
Yeah. I think much more important is this next one, committing generated files. Let's say you're working on your thesis and you have the LaTeX source there, and then you make a PDF out of the thesis. Do you want to add your PDF to the Git repository? So there, the answer is much more strongly, probably not. Because when you add it there, every time you recompile, it can show this is changed and would update it. And it can be made directly from the source already. So there's really no need to add that there. It's better to have only the things you actually edit committed, and anything automatically generated gets excluded. And you can do that with these git ignore files. So on the other hand, I might save a checkpoint of the thesis if it's something that I expect people to want to look at from the GitHub web interface or something, but that's a separate copy from the one that's automatically generated. Because
Well, I
once you
would
yeah.
add
add
to
it and
this.
record it once, any change Git will want you to update it. Okay, Kela, sorry.
So I would add to this that, okay, so you don't want to save generated, to store generated files in and to track them in Git. But
Yeah.
what you could do and you should do is to maybe you write a recipe on how to get those generated files. For example, if the process is a bit lengthy and complicated, then you can have a script that helps you produce those, or at least some documentation that tells you how to get those, so that you don't actually need to store them there because there's a recipe to get them.
Yeah. And that's what's it? Yeah, and that's something that we'll talk a bit more about next day for in reproducible research, how to automatically generate these things. For huge files, it's usually not good to commit them because it tracks the whole thing and that inflates the size of your repository, and even removing them later doesn't reduce the size of the history. So yeah, better not to do that. And this gets what we said about being too pedantic about things. So if you think it's not good, it's ugly, someone's going to judge me for this, you'll usually stop committing, and then, well, you end up losing things later. Committing unrelated changes together. Again, if it's a small project, I think who cares? The larger projects get, they usually want one change per one commit. There's some problems with branching workflows where things can, well, you can try to make things too fancy, too advanced, or whatever, and, well, either not checking what branch you're on, like with the Git status, or trying to make branches that are so big that it eventually can never get merged back. Any other common things to avoid?
Yeah, with
I'd say
branches,
most
just
important.
yeah, don't wait too long before merging.
Yeah. I'd say most important is don't try to be too perfect and let the perfect become the enemy of the good, because I know far more people that regret not having recorded their history than have regretted recording bad looking history. In fact, I've never heard anyone that said, I wish I had spent more time making my commits look nicer. So yeah. Okay, back to the notes, I say. So there's some new questions that are appearing here that are pretty good. So as some quick reminders, we have feedback at the bottom. Please let us know what you thought. Yeah. And if we scroll up, let's see, which of these questions should we talk about? If anyone sees one, please let me know. number 55 for origin, that's the conventional name of it's an alias for the remote. So basically origin means git@github.com / your user / your project name, that kind of thing.
Yeah, and that's the
But
default. You can name it something else.
yeah, the names don't have to match on GitHub and your own computer, but it's probably nice if they do because that reduces confusion later. VS Code, I think this is answered down there. SSH keys. Should we talk about SSH? Maybe let's come back to that if we have time. I don't want to risk going over time, and I think this is probably answered well here. Here's a question about WSL users. So WSL is Windows Services for Linux. It's basically a way to run Linux on top of Windows. So you have access to all the good Linux tools, but on Windows. And this question is basically about how data is stored between them. So you can put some data in a place where it's visible to the Linux side, but not the Windows side, on perhaps vice versa. So it's always important to know where things are stored and think a little bit before you make a new project. Where is it stored and is it accessible in the ways I need it to be accessible? Python files versus Jupyter Notebook we can come back to, but also we have a Jupyter lesson next week. For Codium versus VS Code, I don't use enough to really comment. I know for me, I use Codium and it seems fine. Not all extensions are there, but it's okay. Git add at -p and git commit -p is a good one. Yeah, so if you use git add or commit with the -p option, -p means patch or something like that. And it means that when you run git commit, it will show you every individual change you've made, and you can push Y for yes or N for N and do them separately and add them to the commit separately. And in fact, it's probably the most common way I use to commit things because it shows me everything before I add it, and I can select only the stuff that goes together. It works well for small situations, but if I think it's going to get complex, I'll use git add separately from commit.
Although it may be, for example, convenient if you have different changes in one file, and then you don't want to actually git add the file, then you'll have to have this option. But it is advanced. Sometimes it's better to just undo some of the modifications and commit one by one.
Yeah. Let's say, or this is a good question here. So it's about the not tracking generated files and the sharing with collaborators. So let's say you're working with someone on a manuscript that's written in LaTeX. So if they want me to add the results to the repository, we'd have to be sharing the tech source file and not the PDFs. If someone sends me a PDF, I can't really commit that because it doesn't do much. I have to basically convert it back to the source. So I think that's not completely inconsistent. And if it's Word docs and Word docs is the actual source that we're using to modify things, then yeah, there have been times that I've added that to Git history because there's no other option. Permanently removing things from history. Yes, this can be done, but it changes history and will everyone else will have to update their repository for this new history. So it's a common thing to do. People accidentally commit things all the time, but the recovery is definitely an advanced process. So it's better to try to avoid this. Just because you remove it from GitHub doesn't mean it gets removed from everyone else's repository. Yeah, and what do you know? It's right on time. let's scroll down and let's talk a little bit about this. Where was it? The reminder thing, which I'm moving to the bottom. So tomorrow we continue with, oh, we have a visitor. Okay, tomorrow we continue with Git Collaborative. And in Git Collaborative, we are all contributing to the same repositories. And we are allowing, like, so since we're contributing to some central repositories, you need to request permissions before it begins. And that's done via this this box here. You'll also get an email about it, but please do this in advance, so that way we don't have to rush to give everyone access during the course tomorrow. Good news for day one or day, maybe someone else can write stuff here because my hands are full. But it is so tomorrow is more practice for everything we've done now. So if things are a bit confusing, don't worry. Come back tomorrow and you'll see it again, and we can do it more slowly. And by seeing it in real life being used for something, it will start to become more clear. So it has both command line, vscode, and GitHub web interface tracks. So you can still follow each of the different tracks depending on your needs and your interests. So if the command line part is too hard, don't worry. You have the other options. Yeah, anything else I'm forgetting? Let me look in the chat here. Yeah, I guess. Can anyone else think of anything before we say goodbye? Okay, Michaela, I think you
No,
said
thank you.
something, but
Yeah.
you're muted.
No, I think
Yeah.
we covered a lot of things. And
Okay,
yeah.
great. So, yeah, let's go then.
See you tomorrow.
See you
Okay.
tomorrow.
Bye, everyone.
Okay, bye.
Bye.